Let us now discuss today's LeetCode POTD problem. Problem number 2593. Find score of an array after marking all elements. So here we are given with a nums array. Now we need to take the minimum. So here from this we need to take the minimum element and we need to mark it down. So we need to mark it down. And when we got this minimum element, we need to we need to add it to the score. We need to add minimum element to the score. Now, so here we got a minimum element. Now, after getting this minimum element, we need to mark it down. And also, if you have a previous element, previous index, or a next index, we need to mark them too. So that means first thing we need to do is take minimum element, add it to our score, and the third thing is mark the current index, and next thing is previous index and the next index. So these two are these two are having constants. That means if we are at this index, let us say we are at the index of 0, and we are having 0 as the minimum element. Now there is no previous index here, so we need not to search for the previous index. No, when we are at this index, then we need not to check for the next index, so we get out of the bounds. So let us go with the given example. So in the given example, we are given with nums is equal to 2, 1, 3, 4, 5, 2. So from this elements, we have 1 as the minimum element. Now let us mark 1. Initially score will be 0. Now it has become 1. Now 1 has marked, and there is a previous index 2 and there is a next index 2. So we are taking these two. Now, the question said that we need not to take the marked indices. This is the need of marking these indices. So when we got these indices, we need not to check for the minimum element in them. Now we have 1, and then we have chosen 1, and next is the next minimum element we need to check from here. Now 2 is the minimum element. Let us add it to the added to our score. Now we got 2. There is no so we are marking it. No, there is no next index, but there is a previous index. So here we are marking this 2. Now after marking these, we are only left with 4, and 4 is the minimum element as it is having only 1. And we are adding if you add 2 to 1, it will be 3, and if you add 4 to 3, it will be 7. Now there is no previous or next indices. That means we are removing these elements when we are marking the indices. So when we got 4, we are marking it. Now the array is empty. Now the score which we got is 7. This will be our output. This is the example one. Now let us go with another example. Nums are given as 2, 3, 5, 1, 3, 2. Now the minimum element from this is 1. Let us initialize our score with 0. Now we got 1. This is the minimum element. So add this to our score. Now the adjacent elements and the current indices are also need to be marked. Now I have marked the current index, and I have marked the next index, and I have also marked the previous index. So we need not to take these three elements for consideration of minimum element. Now after this, we got 2, 3, and 2. 2 is the smallest unmarked element. Since there are two of them, we choose the leftmost one firstly. Now we got this. If you add 2 to score 1, it will be 3. Now 2 should be marked, and also there is no previous index. There is a next index, so we will be marking this. So these elements are done. We have marked this. Now we are only left with 2. So this is the minimum element as it only contained in the array. Now we need to add this to our score. 3 plus 2 will be 5, and we are marking this down, and the array is empty. So we have no other elements. So our output will be 5 in this case. So this is the example. I think you got about the examples. So our first observation is having a minimum element every time, and also store the index of it. Now this is the first observation, and the second thing is having the marked or unmarked indices stored in a set. That means when we got this unmarked indices as a in a set, we need not to search for the indices which are marked. This will reduce our time. So these are the two things, and we have the minimum element every time, and we need to store the index in a data structure. I will be telling you what is the data structure. Now having the marked and unmarked indices stored in a set. So how it will be helpful when we take this set 1, 2, 3, 4, 5, etc. Now if you take this indices, think in a data structure, we got the minimum element and the adjacent indices index as 3. Now, you will be finding this 3. If it is present in this set, we will be removing this element from the data structure, and also we will be removing this one and also the previous one and also the next one from our set. So, this will be removed from our set. So this will be unmarked. This will be unmarked. This set should be named as unmarked. So think about this. What is the data structure which stores from minimum to maximum? Minimum to maximum. So it will be storing the minimum element and the next minimum. Sorry, and the next one, and here it will be storing the maximum one. Here the minimum one and the index every time. So if you see clear, if you see clearly, it will be a priority queue. So by using the priority queue, we can solve this problem as it stores the minimum one at the top. Now, let me explain you about the algorithm. First, initialize a priority queue. It will be storing a pair of int comma int. This is the element and this is the index of that element. Now, we will be naming that as PQ, and as I said, set of int will be marked. Sorry, will be named as unmarked. Now, for I is equal to 0 to n, store that in our priority queue. Let us make a pair out of nums of I comma I, and also we need to insert into our unmarked set. Not insert our I into our unmarked set. Now the first thing, if you initialize our score to int, it will be a blunder because we have asked for returning a long type. So we will be initializing long score is equal to 0. Now, how to run a loop till that where there is no elements left in the array? That means we need to remove the top we need to take the top element in the priority queue and we need to remove. So we will be doing that until priority queue is not empty. We'll be stopping if the priority queue is empty. Now we'll be taking the top element and we'll be popping from the pq, and then index is equal to top dot second. We'll be find index inset unmarked. So if you got this index, then only add add our element to score. And only if we got this index in our set, then we'll be finding index plus 1 and index minus 1. So we'll be removing index plus 1 and index minus 1, and also the index from unmarked. We need to erase from the unmarked set, and lastly we will be returning, after this loop we will be returning our score. So you will be getting the code in few seconds. If you like this video, share to your friends, do like and subscribe. Thank you.